Okay, in this video, I will talk about logistic regression. In logistic regression, why are we minimizing the logistic loss? Where that logistic loss come from? Actually, it's also from the maximum likelihood. So now the question is, what cost function should we use for probabilities? Okay, so in the logistic regression, we assume that we assume the actual probability for a point xi in class C is yi, and the predicted probability is by our regression, so predicted probability is hxi. Okay, so how do we derive the likelihood function based on the based on the based on xi? Actually, that's related to the binomial distribution, right? So if you assume the true probability is yi and the predicted probability is hxi, so how do we quantify this probability? Actually, if we observe image, we observe some big number beta duplicate copies of xi. Okay, and where the with yi times yi is the probability, right? Suppose it's 0.5 50% chance to be in class C. So now if we have the flip the coin beta times, so yi times beta in class C, okay, and the failure probability is 1 minus yi times beta, not in class C. Okay, then actually the likelihood function is likelihood is given by, so now suppose we have some model H based on some covariance xi, we estimate some probability y hat I, and based on the x and y. So the likelihood function is that for each observed data, so we observe So how do you think this? How do we construct likelihood function? Actually, the likelihood function is that suppose we can have some h function which is a function of the covariance that can generate labels for these sample points, and the likelihood of so the likelihood for generating these sample points will be it's like a okay, it's like suppose you can get this yi times beta heads, right, with the probability hxi multiply 1 minus hxi to the power 1 minus yi beta. Okay, so this, the bigger this one, so the higher, the more close this hxi to this yi. Okay, and then we go through this to every data point. Okay, so the idea is that the higher this likelihood hxi we have more higher likelihood to generate labels. You can think it's tossing a coin, tail or head. Generate labels with yi beta high success and 1 minus yi beta failures. Okay, so that's the reason behind this log likelihood function. And actually, due to the computational issue, if you have a very small number to some power n and multiply them together, this will have very small tiny number. Usually it's not accurate if you calculate the product directly. So usually we calculate the log likelihood. So the log so usually we use small LH, which is given by the natural log L H xi x y. Actually, this can be rewritten as, so the production becomes to the summation, right? Since you take the log and take a log, the power comes down. So the yi beta natural log h xi. Okay, plus 1 minus yi beta natural log 1 minus h xi. Okay. Actually, this beta you can think is constant. You take it out, so it's beta times, and we can add a minus to every term. So it's I from 1 to n negative yi natural log h xi. So you can think this is observed y, right? This is a predicted y, plus minus 1 minus yi natural log 1 minus h xi. Okay, so maximize this, the constant beta does not matter actually. So this is, so the punchline here is max the log likelihood, because log transformation is monotone transformation. So the maximizer for this one is also maximizer for this one. So maximize log likelihood is equivalent to maximize the followings, or the minimize the followings. Summation I from 1 to n. Actually, this is a logistic loss. Between the observed y, observed y with predicted y. Okay, so this is exactly what we're doing in minimizing finding the parameters in the logistic regression. If you check our last class notes, so we are actually minimizing this cost function. So the reason why I'm talking about this is I just give you an idea why do we minimize this loss. Actually, we are maximizing the likelihood function. Okay, so this is the justification for the logistic regression loss function. So this weird loss function comes from here.